So next up, we're going to have Edward Warren here. Thanks for submitting. Looking forward to your talk here on inter-app collusion. Very neat. Edward?
Hello, testing. A little too close. All right. So I definitely want to welcome everyone for coming out to Firetalks and listening to my presentation. This is my first time at Shmoocon, and honestly, I never thought I would get tickets, let alone have the honor of speaking on stage. So I want to thank everyone again for their time and for checking out my presentation. Before I get into the weeds of it, I just want to go over a brief agenda. It'll be who am I, an overview of Android security challenges, and some mechanisms for inter-app collusion, alongside case studies. All right, so who am I? I am currently a security analyst at Sidara. I do want to let everyone know, however, that I am speaking on behalf of myself as an independent security researcher, and any views or opinions expressed are solely my own. But Sidara is an awesome company that provides MSSP services along with penetration testing services. But what's more important is what I like, and I like bugs, whether it be digital bugs or software bugs, or even gameplay or mechanic-breaking bugs in one of my favorite card games, Magic the Gathering. I'm sure a lot of people here may recognize the Misno glitch from Pokemon. Now, when it comes to Android security, processes are isolated alongside applications, and this sandboxing mechanism will be explained momentarily here. I also just want to go over a quick intro. This is my second time public speaking, so if I sound nervous, it's because I am. So
you're good. You're good. Relax, man. Take a deep breath. You're good.
All right, so back to this concept of the Android sandbox. As a lot of people here, I'm sure, are aware of, Android is based on the Linux kernel, and in order to ensure this kind of process isolation, Android enforces the sandboxing idea. Now, if you think about mobile applications, oftentimes, at least me personally, my cell phone is far more intimate than my laptop. I do most of my banking transactions on my phone. I do most of my shopping on my phone. I may even look at a dating app on my phone. So in order to maintain security, we're going to go into how Android accomplishes the sandboxing, but more importantly, two case studies that I'm going to show how applications can have vulnerable endpoints that can be abused by a malicious threat actor. All right, so as previously stated before, I did mention the sandboxing. Now, part of how this sandboxing is accomplished is because all Android applications are given a unique identifier at install time. And Android, unlike other operating systems, doesn't enforce this permission-based model. So to do things like access your phone or access the internet, even text messaging, it all requires explicit permission from the user. And as part of this process isolation, when applications are communicating amongst each other, this must be facilitated through something called inter-process communication. For those familiar with like IPC and Windows, you can think of like maybe named pipes or pipes on Linux, or even WebSockets if you're familiar with the Windows platform. All right, so now we're going to go over one of the case studies, but not initially. I'd like to just build up a little bit of contextual information so this makes a little bit more sense here. What I'd like you to do is I'd like you to look on the left and look on the right, and you see what appear to be two application icons. I want you to imagine that the one on the left that has the gears on it will reflect a legitimate utility application. And the one on the right will be an impacted phone dialer. In this case, this is not the standard phone dialer that comes with Android. This is a third-party application, but it is right from the Play Store. So let's think about if a legitimate utility wants to be able to access a phone. It has to send a communication or otherwise facilitate that communication. This is where the intent aspect of IPC comes into play for Android. So if you can just think, if you look at intent, think of intent like a messaging object. I like to visualize the intent being like a cart on a train, And in order for a train to move somewhere, you need some kind of background railroad. So if you imagine intent being a messaging object, applications, mostly due to the sandboxing restrictions, have to send data by way of intent, and intent can hold an arbitrary type of data. So once again, I use the train cart and I use the cart and train and the railroad as an analogy. You can think of binder as acting as the mechanism that allows, in the background, that initiate this communication. Now, this part would just be high level. I'm not going to get into the weeds of it, but once again, if you're familiar with IPC concept and Linux and Windows, you can just kind of think of pipes as probably the quickest analogy. Now, the issue, though, is that applications shouldn't be able to freely send each other data. That could obviously lead to all sorts of security issues, unexpected input, sanitization. So ideally, there should be a mechanism that prevents it. Now, before I show the next slide, I do want to let you know that because the Android open source framework allows a lot of flexibility. So even though there's certain restrictions that should be in place to keep apps from having privileges that they didn't explicitly request, there are a few ways of bypassing this. So now I want to bring up this idea of an intent filter. Now this is not a firewall, but it gives a quick visualization. And an intent filter, essentially, I like to think of an intent filter as kind of like an insect net on a door. So you want to let the good cool air in. You want to keep the bugs out. Just to keep things simple. Now this intent filter is actually specified. Well, the contents of the intent filter are dictated by the Android manifest. And just like a ship manifest or a cargo manifest on a train, it essentially acts as the central index where all the application's functionality and permissions are essentially indexed. And we have the Android manifest. So if you think about application A and application B, they want to communicate. In order to get past this boundary, ideally there should be an intent filter preventing two applications from arbitrarily sending information from one to the other. All right, so before I get any farther in about the Android manifest, I just want everyone I'm going to go over a quick explanation for permissions in Android. There's actually 3 types of permissions. There's also special, but to keep things high level, I will briefly go over normal and dangerous permissions. One of the major differences between normal and dangerous permissions is that normal permissions have to be specified in the Android manifest. However, dangerous permissions not only have to be specified, but the system at some point will perform a check to make sure that the user explicitly granted and not that it was just some, if you think about all the, you sign terms of service, you just scroll down and X. Basically, this dangerous permission prevents that kind of buzz, click, and whir knee-jerk response. So one of the permissions we'll be essentially bypassing, I'll be going over, is the internet permission. But there are other normal permissions, like waking the phone or changing the wallpaper, or even accessing network information. So all this is all dictated by this permission model. And for internet permission, typically, if it's listed in the manifest, it would just be auto-granted at runtime. You won't get this kind of runtime check. That runtime checks are for dangerous permissions. There's all sorts of dangerous permissions, things like accessing your phone or camera, reading your contacts. Obviously, if these services are compromised, it could definitely lead to all sorts of malicious activity. Now, I point out call phone because there's actually another permission that's very similar to that. We actually, in Android, we have both a call phone and a call dial. And the difference is very subtle. Call phone will allow you to initiate calls without user interaction. Call dial will essentially pre-populate the dialer. So it still would require the user to click something, where call phone doesn't, it just proceeds. All right, so now we have a snippet of the manifest. The manifest in an application is very long. It includes far more entries. This is a small snippet that reflects the issue. with a component of the Android activity. Now, this is called an inter-app collusion, leveraging improperly exported components. There are many components in Android. It can be things like activities, which you can kind of think of as typical processes. There are other things like content providers and broadcast receivers. They dictate things like, they kind of act as like background daemons, and where they're supposed to push information based on different environmental cues. But the important thing though, to note though, is that for one of the case studies, which is a phone dialer, and I've actually found this issue in several dialers, it has an intent filter for action call and accept parameters for telephone. The problem is that there's other things that should have been implemented. In this case, it will just blindly accept action call, action telephone without requiring the activity that's invoking it to have the same corresponding permission. So I'd like you to think of this scenario. Imagine any application just attempting to place a phone call if you have this dial installed. So in this case, if a user has both the affected call dialer, then any application on their device with no permissions are able to place this arbitrary phone call. And essentially, because of the intent filter, this is accomplished a couple ways. Basically, a 10-digit number specified, and that action call, that dangerous action, happens. Here's where things get more interesting. So now, this would have been a safe interaction if they had simply just chose action dial, because that would have prevented them from bypassing permission. Or, in addition to that, the manifest could have also just explicitly required that permission be invoked. So let's think about what happens behind the scenes. Normally, for any application to make this kind of request, call, phone, a runtime permission be checked to do one of two things. For one, to make sure that it has the access phone permission and the manifest, and two, that the user actually agreed. Because so for example, during the installation of this call dialer, you have to explicitly change it to the default caller, as well as a few additional steps, and that's essentially part of where the issue lies. But I'm going to go over some of them. I'm going to show a demonstration momentarily. I just want to provide a little more background information. So in this case, call phone, that permission is listed in the impacted dialer's manifest. So the phone dialer has the permission, but just any random app doesn't. But it doesn't need it because the phone dialer doesn't properly protect its endpoint. So like, for those who work in cybersecurity, you're probably very familiar with defending endpoints, and a lot of times we don't think about endpoints being software-based. In this case, this is an endpoint that's essentially unprotected. All right, so now if post-runtime check, normally what would happen is that this would fail. But due to the poor coding of the application, you're able to place the phone call anyway. And this all boils down to one thing. See this? There's two things that are highlighted here. You see, once again, action call, and you see export is equal to true. That one value, true, is what causes this entire issue. If they had simply just changed, if it simply wasn't exported, because the thing about export activities is that think of an activity as being a portion of an application. So if an activity is exported, it means that another application can invoke it in the context of itself. So like for example, if app A could invoke app B in the context of app B, and that's part of the issue here. But I think, okay. All right. So once again, I want to go over the threat model. Malicious application installed with no permissions can leverage. And once again, I want you to think of a malicious application kind of being like a Trojan horse, a wolf in sheep's clothing. In this case, an application with no permissions is able to leverage it. We're going to go over case study 1, CVE 2023-49002. And we're gonna get right to the video. Now, this first demonstration is fairly simple, but it shows, well, it ultimately shows the effects of another application sending an intent. Basically, there were no activities open. A third-party application could arbitrarily send that telephone data and cause an outbound phone call to be placed. Now we're going to quickly go over case study 2, which is a little bit more interesting. In this case study, a TCL mobile browser, this is actually designed for IoT devices, will allow any device to arbitrarily execute code. Right at the end here. And once again, this is accomplished because this application just allows too many things. It allows unrestricted JavaScript access, and it allows access to DOM API storage. So any third-party application with no internet permission is able to essentially get internet access and have unrestricted access of your browser. And we're going to go over some of the nitty-gritty points here, but essentially it accepts the HTTP or HTTPS parameters arbitrarily, and we're going to see what this looks like in action right now. So essentially, if you look on the right, you see an application with no permissions. And now, on the left, this is demonstrating me trying to log on. Now, if you keep watching, what you'll see here is you'll see me proceed to log on, and you'll see that I was able to reflect back the password. Now, essentially, it's because the browser allows any application unrestricted access. Therefore, because Facebook stores their credentials within the DOM API, you basically can just pull anybody's creds. And the same thing, a similar interaction can happen with other applications. Because with unrestricted access, you can pull things out of JavaScript, and that's how it's demonstrated. And once again, I want to thank everyone for here. I'm sorry that I ran out of time here, but yes. If you want to. And one last thing, I do have a couple bribes. These are, all right, so
bribes.
the audience can't see, but
Wait,
these are copper coins.
Ooh,
They're moving.
I like coins. Oh my goodness.
One, two.
Is this from Norway?
Yes.
Nice. That's 10,000 points right there. I don't think, I actually collect coins, and I don't think I have any from Norway, so this is a big, thank you very much. 1972, 5 with a moose on it. On brand, nice. I'm going to just jump in if you don't mind.
Go for it.
So yeah, 10,000 points for the coin. It's obvious to me that you know your material, so that is always helpful when you're giving a talk. Congrats on being a first, you said it's your first talk ever?
Well, this is my second talk. First talk at Shmoocon.
First talk at Shmoocon, very good, thank you. One thing that always helps when you're doing a talk, I think, is practice, practice, practice. And even if it's by yourself in a room looking at a mirror, always good to practice. I think 1 or 2 more practices I think would have been good for you, but still very good. There was a couple of slides you had. I'm only 10 feet away from the monitor. I couldn't read them. So the point size was a little small, especially on those code slides and trying to pull those Android things up that I couldn't read. So other than that, well done, very informative, enjoyable talk. Thank you.
Okay, I concur with 10,000 points for the moose bribe, the moose coin bribe. It was fantastic. Bug enthusiast. Who isn't a bug enthusiast? 1,000 points. Where would we be without bug enthusiasts? You know what I mean? General bravery of doing your first few talks and everything. I'm what they call a seasoned speaker, as in I'm old and marinated. But I still get stage fright, and I still get it every time. So one, practice is a great, a piece of advice and stuff, but give yourself a break for having stage fright, because, it may never wear off. I'm sorry. It may never wear off.
It doesn't go away.
And I tend to dissociate myself, but good job on that. On the technical side, I loved the fact that you had a slide with dangerous permissions on it. I thought that was very useful. It was a bit hard to read, but I gave you 2,500 points for a useful slide. And then I gave you 10,000 points for the action dial versus action call. You made a safer substitution recommendation, which I thought was super important for this type of talk. So great job there. Thanks.
Okay, so as they're saying, practice helps. Practice by yourself in the mirror is one thing. Get a group of friends together and practice in front of them. It's totally different with an audience. And what's more, don't let them interrupt you as you're going. Have them take notes and then say, this thing here, I have a question, I have a feedback. And that can really help polish a talk. As the previous judges have said, you know your content. And that initial nervousness, we knew before you said you were nervous, and that's okay. And then once you leaned into your content, the nervousness went away because you know what you're talking about. This is your jam, you've got it. And so if you can lean to that comfort zone, that helps. I do think you had more than 15 minutes worth of content. I love that you wanted to give everyone a background, but in a fire talk, there just is not time for that, or it has to be much faster. But, Katie's point about bringing up good substitutions is great. So getting to the important points. I can't just give you all good points. There have to be those constructive ones around fitting your content to the time. So we're going to take 25 points away from that. However, the coin is freaking amazing. I love copper. I love moose. Who doesn't love moose? And so that's plus 100 points. But the fact that you apparently managed to get my birth year is an additional 10,000 points. So I now have a birth year copper moose coin. Also, I loved the slides. I am also seasoned and old, and I went with vanity today and the contacts instead of the glasses. And so keep in mind your audiences will have a much different viewing experience than you will, and that's the other reason to practice in front of your friends, and actually get a conference room if you can, where they're going to be like, that yellow font on the white background doesn't work for me. Not that you had that, but I've seen talks that did. So great talk, and I hope that you will give this talk again in a longer format at another event where you really have time to go into the details, because I think it was a good content.
Seconded. I would love to see this a long form version of this.
Great job.
I love these bribes, and I'm allergic to copper, so there you go.
I was just going to complain about the lack of bribes, but then I'm still blown away by this coin.
Wait, you got 2 coins.
Well, you want?
In front of me.